Black holes are reality's ultimate rule breakers. Cosmic objects so powerful they can literally bend time itself. And what we're learning about them is even stranger than science fiction.
That's fascinating because most people think of them as just giant space vacuums. But they're so much more complex than that. What makes them so special?
Well, imagine the strongest gravitational force possible. These cosmic monsters are so powerful that once something crosses their boundary, called the event horizon, it's gone forever. Not even light, moving at 186,000 miles per second, can escape.
So that explains why we can't actually see them directly. But I've heard something even more mind-bending about how they affect time.
That's where it gets really wild. Due to their intense gravitational pull, black holes actually slow down time in their vicinity. It's called time dilation. An astronaut orbiting near a black hole might experience just a few minutes, while people back on Earth age years or even decades.
Hold on, you're saying time literally moves at different speeds depending on where you are? How do we know this is true?
We've actually confirmed time dilation exists even in much weaker gravitational fields. GPS satellites have to account for time moving slightly faster in orbit than on Earth's surface. Near a black hole, this effect becomes dramatically more pronounced. We're talking about time moving thousands or even millions of times slower.
That's incredible. And speaking of size, I've heard some black holes are absolutely massive.
Let me blow your mind. The largest black hole we've discovered is approximately 66 billion times more massive than our Sun. To put that in perspective, if our Sun was the size of a basketball, this supermassive black hole would be roughly the size of Manhattan.
How does something even get that enormous?
These cosmic giants grow over billions of years, usually sitting at the centers of galaxies. They're like celestial vacuum cleaners, consuming everything that gets too close: stars, gas clouds, even other black holes. And here's something fascinating we recently captured, the first ever image of one using the Event Horizon Telescope.
That's right, that famous orange donut-looking photo. But what happens to everything that falls in?
That's one of the biggest mysteries in modern physics. According to quantum mechanics, information can't be destroyed, but black holes seem to break that rule. Some physicists, including Stephen Hawking, suggested that black holes might slowly emit radiation and eventually evaporate, but this process would take longer than the current age of the universe.
It really makes you think about how much we still have to learn about the universe, doesn't it?
Absolutely right. And here's something mind-bending to consider. Some theories suggest that what we call black holes might actually be gateways to other universes. The mathematics of Einstein's equations actually allow for this possibility, though we have no way to test it yet.
That sounds like science fiction. But then again, so did black holes themselves not too long ago.
You know what's really exciting? We're entering a new era of black hole research. With advanced gravitational wave detectors, we can now hear black holes colliding across the universe. Each collision sends ripples through space-time that we can detect here on Earth.
So what's next in black hole research? What are scientists hoping to discover?
The Holy Grail would be understanding what happens at the singularity, the point at the center of a black hole, where our current physics breaks down completely. We're also trying to resolve the black hole information paradox, which might help us unite quantum mechanics with gravity, the two pillars of modern physics that currently don't play well together.
It's amazing how studying these cosmic monsters might help us understand the fundamental nature of reality itself.
That's exactly right. Black holes are nature's laboratories for testing our most extreme theories about space, time, and the fabric of reality itself. And who knows? Maybe one day we'll find a way to harness their power for interstellar travel or solving our energy needs. Though I wouldn't volunteer to be the first person to test that technology.